with the Assistant Professor, Department of Physics. So in previous video, I explained about lasers and the three types of quantum processes. In previous video, I explained about the three quantum processes, right? Okay, so now the light is exposed to the, so now the atomic system is exposed to the light radiation. So it will involve the three quantum processes. So stimulated absorption, spontaneous emission, and the stimulated emission, right? So in previous video, I explained about the stimulated absorption. So in today's video, I am going to explain about the spontaneous emission and the stimulated emission. Okay, so we know that two energy levels, E1 and E2. So E1 is nothing but ground state, E2 is nothing but excited state. The number of atoms in E1 energy level is N1. The number of atoms in the excited state is N2. Okay, so in stimulated emission, the ground state molecules will absorb the energy. So in the atomic level, atomic system, the number of atoms will be more compared to the number. So number of atoms in the ground state will be more compared to the excited state, right? Okay. So now the H of energy is given to the atomic system. So it will absorb the energy and goes to higher energy level. So this will be called as stimulated absorption, right? So now, so this atom will excited to the excited state. Okay. So this will not remains in the excited state, but so it comes to its original state by releasing the absorbed photon. Okay, so without any influence of light radiation, so this excited atom so comes to original state by emitting absorbed H of energy. So this process is called as spontaneous emission, right? So this is the downward transition. So the stimulated absorption will be the upward transition. So the transition takes place from E1 to E2 level. So in spontaneous emission, the transition takes place from E2 to E1 level. So this is the downward transition. So without the influence of light radiation, so the excited atoms will come to original state by emitting the H of photon. So this is called as spontaneous emission, right? So next one is, so here, so E2 is equal to, so E2 is equal to, so E2, so E1 minus H2. So it will release the H of energy and comes to ground state. So this process is called as spontaneous emission. So the next process is stimulated emission. So again we will consider the two energy level E1 and E2. So the number of atoms in the E1 level is N2. The number of atoms in the E2 level is N2. Okay. So N1 and N2. So normally, so we have the excited atom. So this will be absorbed H of energy and goes to E1 level to E2 level. Okay. So we now, so in spontaneous emission, so here we will not give any type of energy. So it spontaneously comes to E2 level to E1, right? But in stimulated emission, so we have to stimulate this excited atom with the photon HNU. Okay. So we stimulate the excited atom with the H of energy. Then the excited atom comes to its original state by emitting highly energetic photon. So it will emit absorbed photon H. Here also we have stimulated the H of photon. So it will release the H of energy and comes to its original state. So here, so compared to this photon, so this photon have highly energetic photon. So it has unique properties. So this is the laser. That's why the condition will be the stimulated emission. Okay, after the stimulation, so after the instant photon, this excited atom absorb the energy from this stimulated photon. Then it comes to its original state. But that time it will emit the highly energetic photon. So that will be the laser light. Okay, so that it has unique properties. So highly directional, highly coherent, and highly intensity, and high monochromatic source. Okay, so these are the three quantum processes in the light, right? Okay, now we are going to discuss about the Einstein AB coefficient. Okay, so Einstein AB coefficient is nothing but, so Einstein so will be this. So we calculate the so probability of transition. So we have three types of transition, right? So stimulated absorption, spontaneous emission, and stimulated emission. So Einstein has to calculate the probability of just transitions. Okay, so he derived that the atomic system is equal to the quantum level. So quantum level of radiations. Okay, so now we have to find the Einstein AB coefficient. for spontaneous and P stands for stimulated. Okay. So here, so he has to derive the probability of 3 transitions, right? Okay. So now we have to find. So now n is the number of. So n naught is the number of atoms in ground state, and n is the number of atoms in excited state. So now n naught is the number of atoms in the ground state, n is the number of atoms in the excited state. So the due to the probability condition, so n is equal to n naught exponential of minus e by kt. Okay, so n naught is the number of atoms in the ground state, n is the number of atoms in the excited state. By using so distribution function, so n is equal to n naught exponential of minus e by kt. So this is equation number 1. So let us consider two valence level in between ground state and excited state. So E1 and E2 valence level. Okay, so N1 is the number of valence level, number of atoms in the E1 level, and N2 is the number of atoms in the E2 level. So in E1 level, the number of atoms in so the number of atoms in E1 level is equal to